Welcome to SAT School. I am your instructor from satschool.com. This is our fourth video on probability. Now let's get started. So this is where we left on last video. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch that video. Here is practice question 6 and I hope you should have managed this. You should have solved this. Here we have number card which are from 2 to 30 and that gives us the sample space. So sample space in this case will be 29 because we have number card from 2 to 30. So here NS is 21. Now let A be getting a square number. Now square number from 2 to 30 are 4, 16 and 25. So these are three outcomes, or we can say these are three squares number which are from 2 to 30 and NA is now 3. We have three outcomes or three squares number which are from 2 to 30. Now once we have NA, NS, we can find probability of A where NA divided by NS and we have NA which is 3 in this case and NS which is 29. So that is the probability of getting a square number. Next we find the probability of getting a cube number. That is a cube number from 2 to 30. We have cube number which are 8 and 27. So 8 is cube of 2 and 27 is cube of 3. In this case we have NB which is equals to 2, meaning there are two outcomes which are cube number. Now we have NB, we have NS, we can find the probability of getting a cube number, that is PB, which is NB by NS. NB is 2 and NS is 29. Now since these two events, getting a square number and getting a cube number, if you look at these outcomes, they have no common outcomes. Here 4, 16, 25. Your outcomes are 8 and 27. Since A and B, these two events, they have no common outcomes. These events are mutually exclusive. Now we can say since A and B are mutually exclusive, the probability of A union B is just sum of probability of A and probability of B. We have PA which is 3 by 29 and PB which is 2 by 29. If you sum, then that should be equals to 5 by 29 and that is the probability of getting a card which is square number or cube number, that is 5 by 29. So this is how we solve for mutually exclusive events. Now this is a deck of cards. In a deck of cards, we know there are 52 cards of spade, club, heart and diamond. So we have 13 cards of the spade, 13 cards of the club, 13 cards of the heart and 13 of the diamond. From a deck of cards, we get 52 cards. So these are the cards of the spade, club, heart and diamond from 1 to K. I mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and J, Q, K. So for Jack, Queen and King. So 13 cards of spade, 13 cards of club, 13 cards of heart and 13 cards of diamond. This is in a deck of cards. That is 52 cards in a deck of cards. Now this is the next term that is used in probability, mutually non-exclusive events. What are mutually non-exclusive events? Two events A and B, they are said to be mutually non-exclusive events if both the events A and B have at least one common outcome between them, right? A and B, they are said to be mutually non-exclusive events if they have at least one common outcome between them. Just for example, in a deck of cards, just we have seen earlier, there are 13 hearts. In a deck of cards, we know there are 13 hearts. There are 13 spade, there are 13 club, there are 13 diamond, and there are 13 cards. Now we know there are 4 kings in a deck of cards. So these are 13 hearts in a deck of cards, and these are 4 kings in a deck of cards. Now getting heart and getting king, these are two events. If A represents getting heart and B represents getting king, then if you look closer, there is one common outcome between them, meaning there is the king of heart in getting heart and there is king of heart in the getting king. So if these and these are two different events, in these two events there is one common outcome. That's why this is called mutually non-exclusive event. So the common outcome here is king of the heart, and that's why these two events are mutually non-exclusive. Again, if you see the definition, A and B are said to be mutually non-exclusive if they have at least one common outcome. Your common outcome here is the king of heart. That's why they are mutually non-exclusive event. Now, in case of non-mutually exclusive event, we have a relation where the probability is equals to PA or B or PA union B, PA plus PB minus PA intersection B. So this is the relation for mutually non-exclusive event. Again, two events A and B are mutually non-exclusive if they have at least one common outcome. Here in this case, this is the king of the heart, which are present in both events. That's why they are mutually non-exclusive events. Now let's see one example related to mutually non-exclusive event. This is a practice question 7. The question is, find the probability that a number chosen at random from the positive integers between 10 and 20 inclusive is a multiple of 5 or a multiple of 2. We have a number which are from 10 to 20. So if you count 10 to 20, the ns will be equals to 11 because they are inclusive. Now we have ns 11. Now let A be getting a multiple of 5. Now let's find multiple of 5 from 10 to 20, and those are now 10, 15 and 20. So these are three outcomes, or these are three numbers which are multiple of 5. In that case we have NA equals to 3. Now if we have NA and NS, we can find the probability simply using NA divided by NS, which in this case 3 by 11. Now we can also find the probability of getting a multiple of 2. Let B be getting multiple of 2. Now multiple of 2 from 10 to 20. So these are multiples of 2. That is 10, 12, 14, 16, 18 and 20. Now we have 6 outcomes where NB equals to 6. Now we can find probability of B or probability of getting a multiple of 2, NB by NS, where NB is 6 and NS is 11. Now if you look closer, this is outcome 10, 15, 20, and if you look at this outcome, we have two outcomes which are common. Here is 10, here is also 10, 20 and 20. So these are two outcomes between two events A and B. A is one event, B is another, between these two events we have two common outcomes. That's why A and B are mutually non-exclusive. In mutually non-exclusive, now we can find in A intersection B, which is 2, because we have two common integers or two common outcomes. Now to find probability of A union, intersection B, this is NA intersection B divided by NS. Here is N A intersection B is 2 because there are two outcomes which are common. This 10 and 20, here is 10 and 20. So these are two integers which are common in A and B. That's why this is 2 and this is 2 by 11. Now for mutually non-exclusive event, we have a relation for probability of A union B, which is PA plus PB minus PA intersection B. We have PA, which is 3 by 11, and we have PB, which is 6 by 11. And similarly, we have PA intersection B, which is 2 by 11. Now, if you simplify, then that should be equals to 7 by 11. And that is the probability of getting a multiple of 5 or a multiple of 2, which is 7 by 11 in this case. Now this is practice question 8. A card is drawn from well shuffled pack of 52 cards. So this 52 represents here NS, that is a sample space. Now next is, what is the probability that the card so drawn is either a king or black? Now we know in 52 cards, in deck of cards there are 4 kings and there are 26 black cards. Now this is the case of mutually non-exclusive. Why? Because there are 2 black king and a 26 black card, where 2 kings are common in both events. That's why this king of spade and the king of club, these are 2 black card, and here is a 26 black card in a deck of card. So you can find this, just follow the process that we did for practice question 7 and you can find the answer. I want you to try this question. So thanks for watching. This much for today. I'll see you in next video. Take care and don't forget to subscribe and press the bell icon so that you can get a notification as I upload my video. Take care. Bye.